In this lesson, you'll learn how to add rational expressions with unlike denominators. How can irrational expressions be used to describe elections? The President of the United States is elected every 4 years, and senators are elected every 6 years. A certain senator is elected in 2004, the same year as a presidential election, and is re-elected in subsequent elections. In what year is the senator's re-election the same year as a presidential election? This is a classic example of a problem they use to illustrate the least common multiple. The number of years in which a specific senator's election coincides with a presidential election is related to the common multiples of 4 and 6. The least number of years that will pass until the next election for both a specific senator and the president is the least common multiple of these numbers. The least common multiple, abbreviated LCM, is the least number that is a common multiple of 2 or more numbers. To find the least common multiple, we want to start out by writing our numbers as a product of primes. So I did 12 already. 32 we could do 4 times 8, 2 and 2, 4 and 2. So 32 we only have 2's. And 1b and 1c. So the least common multiple, we need to pick out the most factors of each number. So the most factors of 2 is 5 2's. The most factors of b is 4 factors of b. The most factors of c is the 5 factors of c. And I left out 3. So the least common multiple is going to be 2 to the 5th times 3 times b to the 4th times c to the 5th. So the variables were actually written in the form we wanted them already. 2 to the 5th we know was 32 times 3 would be 96, and we have our b to the 4th, c to the 5th. So this is the same process that I'm doing with the 7th graders. And I was surprised to find out that the 7th grade book even had the variables. Now, to find the least common multiple of two polynomials, we want to factor them first, just like we wrote those as a product of primes. So we need factors of negative 28 to give us a sum of negative 3, so negative 7 and positive 4, and factors of 7 to give us a sum of negative 8, negative 7, and negative 1 will do the trick. So the least common multiple, both numbers have an x minus 7, so we only need to write it down once. Then we also need an x plus 4 and an x minus 1. You can be very thankful that the book did not require you to multiply that out, and let us leave it like it is. Recall that to add fractions with unlike denominators, you need to rename the fraction using the least common multiple of the denominators, known as the least common denominator, so that's where we're headed. Use the following steps to add rational expressions with unlike denominators. Step 1, find the least common denominator. 2, change each rational expression into an equivalent expression with the least common denominator as the denominator. Step 3, just add as we did with like denominators. And then step 4, simplify if necessary. I like the vertical format that I used with the 7th grade when getting common denominators. It gives us a place to multiply. So the 5z is going to be my common denominator. I don't need to multiply this guy by anything. I'm just putting a 1 in there to make it happy for those of you that feel the need to multiply by something. And I'm going to take the bottom fraction times 5 over 5. 5 divided by 5 is 1. 1 times anything's itself, so we're not changing the fraction, just how it looks. So first guy stays as it was, and the second fraction is going to be 5z minus 30 all over 5z. Now that we have our common denominator, we can add the numerators. So we get 6z minus 28 all over 5z. There's no greatest common factor that'll help us reduce, so we're just going to leave it as it is. Okay, I did factor it out, but just to show you, it doesn't work. Either answer is fine. Find. Great directions. Okay, so to add these two fractions, we need a common denominator. So I try to model, this is how I would write it down from the book. I would go ahead and factor this guy as I wrote him down in the first place. So now I can see that I need another x minus 3 on my second fraction. Now this second numerator, I'm going to want to FOIL that out so I can combine my like terms when I add my numerators. So I'm going to have x squared minus 3x plus 3x, which of course cancels out, minus 9. Adding my like terms, I have x squared plus x minus 2. And factors of -2 that give me a sum of +1, just in case I could cancel, but I can't. So once again, either form of the answer would be fine. Rewrite rational expressions with unlike denominators using the least common denominator, then add.